So let me start again. I will be a little bit slower this time now. So I said data is an important asset in any organization, and data serve two important purposes. I don't know if that English correct. They serve two important purposes. Is it purpose or purpose? Purposes. Jesus, in English. Okay, two important purposes. I think that's correct. Number one is for operational use, and number two is for analytical use. But when we say operational use, we are talking about the day-to-day operations of the organization, right? Now, for operational use of data, we usually use what is called operational systems. And I'll mention that example of operational systems are our ERPs and our CRMs, for example. In different companies, they use different ERPs for their day-to-day operations. I mentioned ERPs like the likes of SAP, the likes of Oracle, NetSuite, the likes of, there's a lot that even me, I don't know. A lot of ERP systems, but I know SAP is very, very popular, right? And some companies also use maybe like Dynamics 365 ERP, some use Dynamics 365 uh, CRM systems. Does anybody understand what I mean by ERP and CRM? Or is it something that is new to you? ERP and CRM? Anybody?
I think I do. For instance, ERP system are mostly used in are mostly used in retail store to manage your daily operations. For instance, maybe I think I have an example of let's say a supermarket that is taking stock of their products in the inventory. So usually they use those kind of tools to just enter each product item, the price, and then before they distribute it to different outlets. So
Okay.
there's
So people
one
that
I
use
know
it.
about.
Okay.
I don't think the name is popular because I don't even like the software. There's one called Store App that a lot of supermarkets, a lot of malls use here in Ibadan, which
Okay.
so yeah, so that's it does the same thing. It helps them to manage their daily operations of item or goods, and they enter it into the system, and the software is already inbuilt. They just enter the products, and before they distribute, they enter the product, they enter the price of the product before they then send the product to different outlets. And from the outlets, whenever a customer purchases, you just pick the products, you can then go to the system, and through the scan code, the scan code will reveal the price, and then you pay. Then maybe they will deactivate the code, and then they will give you the product once you paid. So that's
Okay.
my understanding of ERP.
Okay. Okay. Thank you. Thank you, Isaiah. Any other person? You understand ERP?
Yes, sir. Good evening, sir.
I don't know who's talking. I cannot see you.
Tosin Balogun, sir.
Okay. 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 Yeah. So
Yes,
you
to
understand ERP?
me,
Can you explain it to people?
ERP, like the two places I work as an account. So we
Okay.
use ERP for, first thing is that from that ERP we can get a lot of data. I mean, that is where the data, both uh, product we purchase, and let me say
Mm-hmm.
receivable and receivable and
Mm-hmm.
anything going out. Let me just put it down. There's a way to purchase and receivable. So
Okay.
any
Payable and
customer,
receivable.
anything. Yes, sir. Thank you, sir. So anything customer, any money, anything. So the ERP stores everything. If you are creating new customers, if you are creating anything, the product, everything, both the balance sheet. So that is for ERP, and that's why you call, I think, enterprise planning, or something like that. And then for me, CRM, little I know about CRM is that it's just for customer base. And also where I work presently, also, we also use ERP. We use newly ERP, and then from the ERP we use here presently, there's something
What's the
like
ERP that you are using?
the one we use is Tally. The one I work from my former place is Tally ERP Tally. So
Tally.
and
I
then
never heard of that one before.
I think some people also know from Tally, yes, Tally. I think we use Tally 9. Tally, so there's a way. But
Okay.
this one presently we use ERP, but it's not Tally. But this one we just it's not. Let me say it's just coming through the website. Then we input our own personal email and password. And then this one when we input, it's also display everything for distributions, for retail. So everything we can see each payment to set off to offset any balance. So they can see how there's a chart every month that it will be displaying our sales per day, per month. So there's a chart. Let me say the chart is just like a line chart. So for each month.
Okay.
So
Okay.
that is what I also know about ERP, sir.
Okay. Thank you, sir. Grace, your hand was up.
Okay, good evening, sir. So
Yeah.
I wanted to say that ELP that I know is for inventory stock, just as Isaiah has already rightly said.
Mm-hmm. Mm-hmm.
ERP
Mm-hmm.
is mostly used for inventory stock, especially in manufacturing company where your
Mm.
products, when we produce all the stocks in the factory as at that period, will be
Mm.
on the ERP. And if you are to distribute to distributors, if you are to give out those goods to
Mm.
distributors, it will be
Mm.
there for on their customer ID. So
Mm.
distributors to us are customers. So for every customer ID, their stocks and their order are always stored on the ERP. So you see that the
Okay.
inventory of it's just basically used to manage the inventory of the company.
Mm. Mm. Okay. Thank you everyone for your contribution. Okay, Adedi is something. Let's do it. Let's do it fast, please.
Okay, good evening, everyone.
Good evening.
Yes. Okay, my own understanding of ERP. I think ERP, because where I'm currently working, we use ERP, SAP, S4HANA. It
Yeah,
is
thank you.
used
God bless
for
you.
the operation, general
Thank you.
operation in an
Mm-hmm.
organization, starting from the
Mm-hmm.
inventory, everything, even HR. They use the ERP
Thank
in
you.
paying staff. It is used in
Yes.
accounting as well. Accounting uses
Thank
in
you.
warehouse
Mm.
production. So ERP just cover all the operations you do in a
Everything.
particular
Thank you.
company. Everything,
In fact,
everything,
you said
every decision on the
what I was about to say
everything.
is what you just said down. So because I know
Hello,
see people mentioning that it's used for a particular thing. ERP covers everything now. It
it
now
covers
depends on the
everything. It's not
ERP.
about one
Uh-huh.
particular thing. Even starting from procurement, sales, everything.
Procurement.
ERP
Thank you. God bless you.
everything. So it's just like
Yes.
a end-to-end operation for every organization. It's not based
Thank
on
you, sir.
inventory alone. And for the
Thank you,
CRM,
sir.
currently what we really use the CRM for is just for the customer service operations, how we
Ah,
interact with
you are too much. You are
customers
too
and
much.
all those things. So that's just my own
Yes. Thank you,
idea.
Alini something. I appreciate you. I was about just saying what you just said because many people are just mentioning ERP that yes, they're saying it as if it's only meant for inventory and stock and those things. No, it's meant for general daily operation. So it now depends on the vendor. Maybe it's Microsoft or maybe it's Oracle, or maybe it's SAP, or maybe it's every other one that I don't even know their names, right? But any system in an organization that is used for daily operations, they are called operational systems. They are the systems that we use in entering the data. Do you understand? So, for example, now I said CRM, if a customer calls in to make a purchase and you are a customer service person and you are using a CRM system, you will enter the customer's information, what they want to buy, their location, everything. You enter it, their address, delivery address, everything. You enter all those information inside the CRM systems, right? So that we use the operational system, CRM or ERP or whatever you guys want to call it. We use it for daily operations of the organization. For example, for your procurement, HR, some HR, they use SAP for payroll, right? For example, as a staff, you can have a login, you can see your pay slip and all on SAP. Do you understand? You can check your number of hours, how many hours, days of leave you are entitled to, that in a particular fiscal year you have accumulated. So all those systems that we use to do daily operations of the business, they are called operational systems. We use them in entering the data. itself, right? And another purpose of keeping data, keeping information on record in an organization is also for analytical purposes, which is the part where me and you comes in as a data analyst, as a Power BI developer, right? So when we say analytical purposes, it means that creating insights, creating reports, creating dashboard that the stakeholders will use to know the standpoint of the business and to know what is the next move or strategy for the business, right? So creating data analysis from those data that are being entered with the operational systems, right? So because we want to be able to use that data now to impact the business, to impact, the stakeholders that will make these decisions. We want them to see the overview of the whole business, how we are performing, right? So that is the second purpose of data in an organization. Also for operational purposes and for analytical purposes. Please, is it clear to us before I move on, please?
Yes,
Is
it's
it
clear.
clear? Okay, thank you. So far, I get one answer, and I'll just move ahead. Um, Also, I now said that operational system, we've defined that. Now, what is now our analytical system? That is our data warehouse, right? But no, before a data we get to data warehouse, it must be first be in a database, right? A default database that have been set for that data, for those data to be in. So let me give you an instance. I now said, for example, let's look at e-commerce organizations, or let's say Bolt or Uber, for example. When you download the Uber app for the first time, you sign up, right? When you sign up, what do you enter when you sign up? You enter your name, right? Probably your first name, your surname, your phone number, your email, your location, your gender, depending on what the sign up is telling you to enter. Some details it will tell you, it might be optional for you to enter those details. Some might be compulsory. For example, your email and phone number will probably be compulsory. Your name will be compulsory for you to enter when you are doing sign up on our application, right? I'm not saying that those information that you are entering, there is a database at the back end of those applications that is powering those applications. That when you are entering data, those information are going into that database. So that database has data in its raw state, in its raw form. Is that clear to us now? It has not been cleaned
Yes,
or
yes.
anything. Every raw data is going straight into that database. We call it OLTP, online transactional processing, OLTP systems, right? So those kind of database, they are raw databases that the information coming from the different applications, right? They enter into that database, right? Now, I now say that the way that database is optimized for both fast read and fast write. So what does that mean? When I say fast write, as you are entering that data with that application, is writing the information into that database, right? That information you are entering is being written inside the database. So that database is getting the data, right? It's storing data that you are entering from the application, right? Now, that database is not analytical friendly, right? In the sense that what you have there is just the raw data as it is. You've not done data cleaning, you've not done data validation, you've not removed unnecessary columns that you don't need for your reporting. It's just the way it is from the time you enter data from the operational systems. That's the way the data is going to be. That will be the state of that data inside the database, the OLTP, right? Now, as a Power BI developer, as a data analyst, or whatever we call ourselves, what we use for reporting is usually the data warehouse. That data warehouse is analytical ready, and we call that data warehouse analytical systems, right? They are the ones that we use for our reporting, for our analysis, to create dashboard, because the data has gone through transformation, right? The linking activity between the OLTP system and the data warehouse, I mean, it is the OLAP. We call them online analytical processing. OLAP. That's the data warehouse. It's called OLAP, right? The linking activity between them is the transformation, right? In between OLTP and OLAP, the OLAP is what? Transformation. So now, when you have now transformed the data, you have cleaned it, you have restructured the data, you have removed columns that are not necessary for your reporting, you have masked some columns so that people don't see sensitive data and those things down, and you now move it to another database called a data warehouse. The linking thing between them is transformation. Do you understand what I'm trying to say now? So that is the difference between OLTP and OLAP, database and data warehouse. But data warehouse too is also a database. Oh, don't get it wrong. Oh. But it's just a database that is analytical ready, that serves analytical purposes, right? Compared to the database that, as information comes in, it drops inside it. That's the difference between OLTP and OLAP. Before I move on, is there any question on this part? Mr. ASD,
I have a question, please.
ask me, sir.
You mentioned that at a point you have the raw
Yes.
data stored in the warehouse, right?
In a database.
Now,
I didn't say warehouse. Oh.
in the database.
Yeah.
Now, one thing I know is that database, can that database be called maybe a data lake, because we have an unclean, maybe should I say unstructured data inside?
Thank you very much, sir. So you can call it a data lake too, or in some data architecture of some organizations, right?
Yes.
They usually create data lake different too sometimes from a database. Do you understand?
Okay.
So where they're now going
Yes.
to like separate the data, maybe based on some particular domain. So say the finance guys, this is your own data lake. The procurement guys, this is your own data lake. So
Yes.
the conventional data warehouse, we connect all the different entities together.
Yes.
You understand? But sometimes
Yes.
data lake might just be for, depending on the architecture that they are building in that company, the data lake can just be for domain knowledge, for domain, to separate
Okay.
different entities. You
Okay.
understand? And as you
Yes.
said, that data lake for storing both unstructured and structured data, yes, they can do that too also. But data lake is another concept that is a little bit in depth. I don't want us to go into that part for now, right? Just understand database and data warehouse for now. We are still going to go into data lake later, right? Which
All
for
right.
I'm sure will be contributing a lot to that part because
All
of its
right.
fabric knowledge. You understand? So, what I'm just preaching today is that database is where the raw data where the data is being stored, and it's optimized for fast writes. And what that means is that I use an example of Uber, that me and you can order Uber the same time, the same seconds, the same minutes, the same day. And the database should be optimized for fast writes, a fast write. It means that different data can enter into that database at the same time. We don't have to wait for each other. Do you understand, Mr. ASD? So
Yes, I
that
do.
is
Thank you.
that is the conventional database, right? So when we say data warehouse, it's also a database, but it's a database for analytical purpose. That is where we can connect our Power BI to start building our reports that has been to some extent gone through some level of transformations, right? And it's useful for the kind of reporting and dashboard that we want to build. Is it clear to us, everybody? Operational
Yes.
systems, analytical systems, OLTP and OLAP. Is it clear to us?
It's clear.
We are
Yes,
just
it's clear.
laying
Thank you.
theory foundation. We are still going to do the practical. Because in this class, there's one assignment that we give you when we get to SQL that you will convert OLTP to OLAP. We are going to do it. And when we get to SSSIS, we are going to do a lot of transformations and move data from one database to another. We will do all of those things in this class. So before I move on, now that we've laid the foundation of database and data warehouse, and we understand the basics of these terminologies, how they are being used. Now, when it comes to the concept of data warehousing and business intelligence systems, data warehouse, and we don't even talk about tool. Tool is not the major thing that we talk about in explaining this concept for people that are just learning them for the first time. The major thing that we'll talk about when it comes to these systems is number one, we talk about storage, right? Uh, Storage is a very important thing to know when we talk about data warehousing. When we talk about, because number one, this data that you are using for your reporting is being stored somewhere, and there are different ways that this storage works, right? Different vendors, right? Depending on what the capacity that you are using, right, will determine how much you are going to be paying for storage. Do you understand that part, guys? So what you are using will determine. There's some vendors that the way they structure their different databases that you are using, right, especially for cloud databases. Uh, some is that you pay for this, you pay as you use. Some is that you already have a particular amount of money you pay, right? Depending on what you are paying for, what you want to use. The how far your data is, how large your data is, will determine what you are going to pay, right? So storage is a very important concept when it comes to understanding the way data warehouse and databases how they work, right? What again do we want to discuss about here? Um, so there's a lot of things that we need to consider uh when it comes to using data. Number one, how do we collect the data? That's the first question that when every company is setting up their database systems and data warehouse or whatever, they need to also ask the question, how are we going to collect the data? Right. Number two is, how are we going to store the data? Number three is, how are we going to process the data? Right. Number five, which is that number four, number five is, how are we going to get value from the data? Right. So that all of these things will now determine how the data architecture is going to look like. Right. So I hope that is clear to us. Okay. Now let's go to the concept of dimensional modeling. So I'll just give you a little background of dimensional modeling, what is star schema, and what is snowflake schema. So when we say dimensional modeling is a technique that is primarily used in what data warehousing, but we also use this also in Power BI also, right? But the concept of data modeling, dimensional modeling, is used in data warehouses, right? Now, dimensional modeling focuses more on user-friendly structures for reporting and analysis. Is somebody called Ralph Kimball. So I would like you to read more about the guy. In the 1990s, he was a thought leader when it comes to dimensional modeling. He contributed a lot to the concept of dimensional modeling. And one of the things that he proposed was that uh, place to structure the data warehouse in such a way that there will be fact tables and there will be dimension tables, right? So that you can separate dimensions from the facts, right? And you can every entity of the business can be well represented, right? So it is structured and organized way of you know of representing different parts that make the whole of companies, operations, right? Dimensional modeling involves creating dimension, which I said earlier, which is the descriptive attributes, and the fact, which is the quantitative data, right? And dimensional modeling is also designed to optimize your query performance because you're organizing your data in logical units, right? So that is a background of dimensional modeling. So the assignment for next week is that you guys are going to read more about dimensional modeling, and you would also read more about Ralph Kimball, who is a thought leader on dimensional modeling. Now, star schema. When you guys say star schema, star schema, star schema, star schema is a type of dimensional model. Is a what? Is a type of dimensional model, right? Now, the structure for star schema is that you have maybe probably one central fact table, which always contains the numerical or the transactional data, and you have the dimension table, which is which contain your different business entities and their attributes. For example, your customer is an entity, and you are going to have attributes like customer ID, customer name, customer location, customer gender, and so many other things that has to do with customer first name, last name, email, and those things, right? And we are going to have also a denormalized what's it called? We usually have most sometimes denormalized fact table, right? That is connected to all these dimension tables, right? Uh, what are the advantages of a star schema? It helps for faster queries. It's easy to understand because you know the facts, you know the dimensions. It's easy to understand. It's good for reporting. Disadvantage or the merit is that with star schema, we can have redundant data, right? Because our dimension tables are denormalized. They are denormalized. Some people might be like, why would you say they are denormalized? But in star schema, we normalize now. So actually, we normalize in star schema because we try to separate the dimension from the facts, which is good. But truth of the matter is that in the real context of things, uh, dimension tables in a star schema are usually denormalized in the sense that if I have customer table, for example, in that instead of me creating different dimensions for customers, maybe like separating, I'll just have customer, maybe on one customer dimension table, I can have the customer ID, the customer name. In that same table again, I'll have the gender. That gender will now repeat in that table because different customers belong to one gender, right? In that same table again, I'm going to have location, the customer's location, and I'm not going to have different locations repeat several times because there are different customers in one location, right? So that is where that denormalized uh, uh, forms when it comes to star schema, when it comes to the dimension tables in a star schema, right? They are always denormalized. And that leads to redundant data because you see a lot of the same data repeating itself, right? That's why we call it redundant data, right? But in a snowflake schema, on the other hand, so a snowflake schema, some people, this is not the same. Some people might want to attack me, but truth of the matter is that a snowflake schema, right, is a variation of a star schema, right? In a snowflake schema, the tables are normalized. Everything is normalized in a snowflake schema, right? Meaning that even dimensions can be broken into different layers. So let's say for example products. For example, you have product dimension. You can have one table called products, another one called product category, another one called product subcategory. So when it comes to snowflake schema, we normalize it to the minimum, to the barest minimum. It means that you can break down a dimension into like different layers when it comes to snowflake schema, right? So the advantage of this is that there's less with data redundancy, right? Because you've really broken down the dimensions, you've normalized it very well, right? But the disadvantage is that it makes our reporting to be more complex. It is slower for performance, right? Because you have to do a lot of joins. It means that, for example, if I have product table, I'm going to be joining the product table with the sales table. Now, that product table will now be joined with the product category table, and we will join with product subcategory table. So there will now be different layers before it gets to the fact table. It means that I can have product category will be the highest layer. I will have subcategory as the middle layer. Then I have the product table before I can now use that product table to connect to the sales table. So there are different layers, right? Because of normalization that we do, right? Because the dimensions are being normalized and there's no room for redundancy because we have normalized even the dimension tables, right? So what I'll just say to this is that the way Power BI is being built and the way it is so Power BI is well optimized for star schema than a snowflake schema, because when you have a snowflake schema on your Power BI data model, it means that there's going to be a lot of there might be a lot of complications, and you might have to be writing a lot of dots that would filter, and you are creating context that would bring in elements from different places to to derive your calculations and your measures. So, but me, for as a person, I usually do prefer to use a star schema because Power BI is well optimized for a star schema than a snowflake schema. So we are going to be when we come next week, we'll start fully, and we are going to talk about uh the star schema in depth. We are going to create some relationship between the tables that we already have in the Power BI file we are using for this class. We are going to be talking, Isaiah will talk about storage modes, which it will go in depth into talking about the import mode, the direct query mode, and also the draw mode. And we'll talk about cardinalities. We'll talk about the four types of relationships that we have. We'll talk about the cross filter direction and the meaning of both, and when to use both and when to use one filter direction and all of those things. Then we'll move ahead to other things that we'll discuss about. And today we've come to the end of today's class. Any question?